In this video here, we're going to take a look at the t-formulae. So the t-formulae are a set of formulae that allow us to express sine theta, cos theta, and tan theta in terms of t equals tan of theta over 2. Now the t-formulae is particularly useful as it allows us to solve trigonometric equations and also prove trigonometric identities, as we can now write expressions that involve sine theta, cos theta, and tan theta into a single variable t here. Now we do also need to be able to derive the t-formulae using trigonometric ratios and the double angle formulae, but before we do that, let's just quickly introduce the t-formulae. So let's have a look then at introducing the t-formulae here. So as we said then, right, when t equals tan of theta over 2, sine theta is equal to 2t all over 1 plus t squared. Cos theta is equal to 1 minus t squared all over 1 plus t squared. And then finally here, tan theta is equal to 2t all over 1 minus t squared. So these three results here, right, are really, really important. Please do make a note of these three results here. Now, it's important to know that these results are not given in the formula book, so unfortunately, just one of those things that we do have to learn and memorize. But you can quote them in your exam, given that you're not asked to prove or derive the results yourself. So there is some good news, right? We don't always have to prove or derive the results ourselves to use them. So let's have a quick look then at how we can derive the t-formulae ourselves. So let's have a look then at deriving the t-formulae. So there's a number of different ways here that you can derive the t-formulae, but for this video here, the way that I want to demonstrate the derivation here of the t-formulae is by using the definitions of the trigonometric ratios and the double angle formulae. So to get us started here then, let's just begin by constructing a right angle triangle with an acute angle of theta over 2. And if we do so, we obtain the following here. So what's important then here with this right angle triangle is this side, so the opposite side here to our acute angle, we need to label that as t, okay? And then the adjacent side here, we label that as 1, and then by using Pythagoras here, right, the hypotenuse must be the square root of 1 plus t squared. Okay, just basic Pythagoras there. So now, by applying the trigonometric ratios to the right angle triangle above, we obtain the following. So as we can see then, sine of theta over 2 is equal to t, so that's the opposite here, over the hypotenuse, which is the square root of 1, plus t squared. Okay, so we obtain this here. Doing the same then for cosine here, so cos of theta over 2, that is equal to 1 over the square root of 1 plus t squared here. So we get the adjacent over the hypotenuse like so. And then finally for tan of theta over 2 here, that is simply equal to t. So that's the opposite over the adjacent. So we get t over 1, giving us t there. So let's continue here then with the derivation of the t-formulae. So as we can see here, right, we don't have quite enough room to do this all on one page. So all I've done here is shifted these results up here, including our right angle triangle. And don't forget then that these results here are what we obtained on the previous page just by using this right angle triangle with acute angle of theta over 2 and our basic trig ratios. Now to finish the derivation here of the t-formulae, all we're going to do is use the double angle formulae. Now starting off then, what you might expect here is sine of 2 theta. As you can see here, right, all we've done is divided the argument by 2. Okay, so rather than sine of 2 theta, we have sine of theta. And in doing so, what that gives us then is 2 sine of theta over 2 cos of theta over 2. Well, we know that sine of theta over 2 is equal to t all over the square root of 1 plus t squared. And we also know that cos of theta over 2 is equal to this here. So we get 1 over the square root of 1 plus t squared. Okay, so once we simplify this multiplication here, we obtain the following. So I get 2t all over 1 plus t squared, exactly as we require. Okay, so moving on then, as you can see now, we now have cos theta. So again, I am using the double angle formulae here. So normally this would be cos of 2 theta, which we just write as cos squared theta minus sine squared theta. But again, all I've done here is divided the argument by 2. Okay, so now what I've got here is 1 all over the square root of 1 plus t squared. We square that, right, because this is cos of theta over 2 all squared. Okay, we then subtract sine squared of theta over 2. So sine of theta over 2 is this here. So it's t all over the square root of 1 plus t squared. So we need to square that as well. And again, once we simplify here, we obtain the following. So I get 1 minus t squared all over 1 plus t squared. Again, exactly as we require here. And then finally, nice and straightforward here for tan theta, just using this basic trig identity here of sine theta over cos theta. So what I'm going to do here is sine theta times by the reciprocal of cos theta, right? It's just easier to work with. So in that case then, sine theta here, as we already know, is 2t all over 1 plus t squared. So basically, I'm just going to use these two results here to find an expression for tan theta. Okay, so as we just said then, sine theta is 2t all over 1 plus t squared. And then we times this here by the reciprocal of cos theta. In other words, just 1 over cos theta. So in that case then, I get 1 plus t squared all over 1 minus t squared. And once we simplify here then, as you can see, they will just cancel like so. And I get 2t all over 1 minus t squared. Again, exactly as we require. And there we have it. So that is a very quick derivation here of the t-Formulae. And as I said, right, there is a few different ways that you can derive the t-Formulae. And I do think I will show a second derivation in a separate video. But for now, I think this is probably the best way to derive the t-Formulae. So you do need to know, I should say, when I can actually speak, you do need to know how to derive the t-Formulae, right? It is really, really important that you can derive them yourself. And you can be asked to do that in an exam. Okay, so make sure that you familiarize yourself with this derivation here or another derivation, whichever you prefer. Like I said, I will cover, a separate derivation in a separate video. Okay, but for now, I think that's the best way. So there we have it. That concludes our introduction here to the t-Formulae. All we're going to do now is work through one practice question. So let's get started then with this practice question. So let's just have a go then at this one practice question here for the t-Formulae. So for this question then, we're told that tan of theta over 2 is equal to 3 over 5. The question then asks us to use the t-Formulae to find the value of the following here. So as we can see then, we've got 4 parts to this question. So let's begin then with part A here. So for part A then, we want to find the value of sine theta here. So for sine theta then, so let's just state sine theta here in terms of the t-Formulae. So sine theta in terms of the t-Formulae is given as 2t all over 1 plus t squared. Okay, so this result here then is just sine theta in terms of the t-Formulae. So what I'm going to do here is use the substitution then of t is equal to tan of theta over 2. Okay, and we're given that tan of theta over 2 is equal to 3 over 5 here. Okay, so basically to find the value of sine theta here, just replace any t's with 3 over 5, right? In that case then, what I get here is 2 lots of 3/5. So 2 lots of 3/5, and that's all over 1 plus 3/5 all squared. Okay, just put this here then into your calculator. You don't even need to do it by hand, right? And if you do this correctly then, what you should find here is we get 15 over 17. Okay, hopefully nice and easy there for part A. Moving on to part B then. Let's do that underneath here. So for part B then, we now have cos theta here. Okay, we want to find the value of cos theta. So again, let's just start here by stating the relevant result then for cos theta in terms of the t-Formulae here. So for cos theta then, this is given as 1 minus t squared all over 1 plus t squared. Okay, again, just replacing any t's here with 3 over 5. So in that case then, what I get here is 1 minus 3 over 5 squared, like so. And that's all over then 1 plus 3 over 5 all squared. Again, just put this into your calculator here. And if you do that correctly then, what you should hopefully find here is we get 8 over 17. We get 8 over 17 there, and that gives us the solution to part B. So moving on now to part C here, where we have tan theta now. So for tan theta then, again, let's just start here by stating the relevant result then for tan theta in terms of the t-Formulae here. So in that case then, what I get here is 2t all over 1 minus t squared here. Okay. Again, just replacing any t's with 3 over 5. So I get 2 lots of 3/5 here, like so. And that's all over then 1 minus 3/5 all squared, like so. Again, just put this into your calculator here. And if you do this correctly here, what you should find then is we get 15 over 8 here. Okay. And now for the very last part here, part D, where we want to find the value of sec theta plus cosec theta. So the sec theta plus cosec theta here, well, we're going to make use here of the fact that these are the reciprocal trig functions. So what I've got here then is 1 over cos theta. So 1 over cos theta plus 1 over sine theta. Okay. Like so. Well, we know the value of cos theta, right? That's 8 over 17. So 1 over that would just be the reciprocal of this here. I get 17 over 8. So 17 over 8 plus the reciprocal then of sine theta. So sine theta, the value of that is 15 over 17. So the reciprocal is 17 over 15, right? I get 17 over 15, like so. So all I need to do now is evaluate this addition here. So you can either do it by hand. I'll just put it into your calculator. Either's fine. What you should get here then is 391. So 391 over 120 there. Okay. And there we have it. So that gives the solution to part A. That's a solution to part B. This here is a solution to part C. And then finally here we have the solution to part D. And that gives us the solution here to, well, it's just this one question for this video, right? But the solution to the question for this video here. And that brings the end then of this video here on the t-Formulae.